Hello, in this video, I will explain to you on how to solve this problem. Let's read the problem first. A fireman, D is equal to 50 meters away from a burning building, directs a stream of water from a ground level fire hose at an angle of theta I is 30 degrees above the horizontal as shown in figure P3.32. If the speed of the stream as it leaves the hose, Vi is equal to 40 meters per second, at what height will the stream of the water strike the building? Okay, let's decompose the initial velocity into horizontal and vertical component. So we will have here, we will have Vi in the x direction, Vix, and also we have this one here, Viy in the y direction, in the vertical direction. So we'll have Vix here is equal to Vi cosine of this angle here, that will be theta I. Good. And Viy here, that will equal to Vi multiplied by sine of theta I. Good. We will have 40 and then cosine of 30 degrees. And we will have also 40 sine of 30 degrees. Okay, the easier to calculate is this one. So I will have 40 times 1/2, right? So we'll have 20 here. And the unit here is meter over second. And this one will be 20 square root of 3, but I need the decimal numbers. So we'll have 20 multiplied by square root of 3. Okay, I will have 34.64. 34.64, and the unit here will be meter over second. Okay, now let's analyze on the horizontal direction, right? So we will have horizontal direction. Okay, we know in the horizontal direction we don't have any acceleration, so we will have constant velocity. Constant velocity. And consequently, we will have this distance here, D, is just V times T, right? And what V? The initial velocity, Vix, right? And then we can isolate for time here. So that is time total of the water, right? From this hose until it reaches the building. So I will have T total. And that will equal to, I think we will have D divided by Vix. Good. So now we will have 50 divided by Vix. But Vix is 34.64. Okay, now let's see here. So we will have 50 divided by 34.64. And we will have 1.44 second. 1.44 second. Okay. Now let's analyze when the water is going up. Okay, let's see when the water is going up. Okay, remember, if we have some peak here in the maximum height, we will have Vy is equal to 0. And we can also use kinematics to calculate the time, right? From the hose until the maximum height. So we will have Vy here, Vt is equal to Vo plus 80. Okay. But then, remember, when it is going up, the only acceleration that works is the gravity, but it is slowing down the water, right? Because we have some initial velocity. Here is 20. And here is 0. So it is slowing the water down. So we will have this A here is equal to minus G, or minus 9.8 meter over second squared. Okay, that's good. Now this final velocity is the Vt, so I'll have 0. And then initially it is 20 meter over second, 20, and then plus the acceleration is minus 9.8, so I have minus 9.8, and then multiplied by t going up. But then the T going up here is equal to 20 divided by 9.8, right? And let's calculate that. So we will have 20 divided by 9.8. Okay, so we'll have 2.04 second. Okay, 2.04 second. However, because this is larger than this, right? The drawing here is wrong. So it has not reached the maximum yet. So the water should be like this here. Like this. It is still going up in this direction, right? So let's write that. So we will have because T up is larger than going T total. Okay, the water has not reached maximum height. Okay, so the water is still going up here and it already reached the building. So we only consider when it is going up, right? So okay, let's calculate that with this time here. So we don't use this time but this time here, and only when it is going up. Okay, let's clean up our slide and do that. Okay, now because it has not reached the maximum height yet, we can use this formula here for the height. So we will have the initial velocity, VOT, and then plus 1/2, then multiplied by the acceleration, multiplied by t squared. However, we have the acceleration because the water still going up. We still have the acceleration is minus g, or minus 9.8 meter over square seconds. Okay, now let's plug the numbers here. So we will have the initial velocity. We know that that is 20, so we'll have 20. And then the time, remember that we use the time here is 1.44 because that is the total time from here until there, right? So time is 1.44. And let's plug this here. So I'll have 20 multiplied by 1.44. And then plus 1/2. And then we have the acceleration, and that will be minus 9.8. And then multiplied by t squared. So we will have 1.44 squared. Okay, so we will have the height. All that we need to do is plug all this into calculator, right? So we will have the height here is 20 multiplied by 1.44, and then plus 1/2, and then minus 9.8, and then multiplied by 1.44 squared. Okay, I will have 18.64. So I have 18.64. And the unit here will be in meter. And that is the final answer for this question. The height of this building is 18.64. Hopefully, I did not make any mistakes during my calculation. And as usual, thank you for watching. And if you got any question, send me your question into this email, rdsatria11@gmail.com. Okay, thank you for watching, and once more, see you in the next video. Bye bye.